All right, I want to take a look at the law of sines, where you're in the side angle possibility here. So I'm going to start with a side down here. I don't know how long this side is. This is going to be where I'm starting from. Let's say I know angle A here. This is a given angle. I know how long it is. And I know how long this is side angle B is going to be up here. So this is side C. So I know side C and I know side A, right? Now, depending on the information, so I'm fixing this side. This angle's fixed, this side length's fixed, and this side length is fixed. So the thing is, if this side length little a isn't long enough, you can think about this side length here dangling down, just kind of saying, oh no, I can't reach the bottom. Well, there's no triangle there, right? You can think about extending that side longer and longer till it tries to get down to this other side till finally there's a spot right there where it just touches, and that would be a right angle, in which case there's one possibility here. So there's some problems here. Either A is going to be less than some threshold, or A is going to equal that threshold perfectly. And what is that threshold? Well, at this situation right here, that's a right angle, then A divided by C is going to be the sine of angle A. So A is C sine A. So when A is equal to C times the sine of angle A, then there's going to be one solution. If A is less than that critical value, then there's no solutions here, right? No solutions. On the other hand, if A is bigger than that, then there's some other possibilities. So let me get this drawn in here again. This is fixed angle A, right? This is a side length C here. Angle B is up here. Now, if A gets to be a little bigger, it turns out that you could come down here with side length A, or you could come in here with side length A. That is, the same information, this angle, this side, and this other side here, this opposite side A, there's two different possibilities. This angle's the same, that side length the same, and both of these edges are the same length. So you could be looking at this angle down here, or you could be looking at that angle over there, and they're not equal to each other. They're supplements, because this angle is the same as that one, so these are supplements right there. Right? The law of sines will only give you one of those answers, though. So when I try to do this, where A is bigger than, actually I'm going to write it this way, A is somewhere in between C times the sine of A and C, then there's two solutions. When A gets big enough so that it's actually bigger than side length C, then this one doesn't, you don't have this option in here. You only have one option. So when A is, here's C, here's A, when little a is big enough that it's bigger than C, you get this answer out here, you get this A out there, but the other one, which would be if you took this side and swung it around, like say, I think of this as sort of swinging on a circle there. It hits here, it hits there. This one hits here, the next time it would hit would be clear over here, it would be way over there, and I'm not using that angle anymore. So then there's only one solution. If A is greater than C, then I'm back to only one solution. And in the previous video I made sure that was the case, so I knew that I had only one solution. Right? So let's try an example of what happens here. In fact, let's try one. Well, I did this example. We'll do one of each of those there. So here we go. Let's start out with our angle here. I think in the previous example I used 52 degrees in here. So let's do that. Let's give this a side length of 7. And over here, so this is A, B, C. This is a side length of 2. Right? So, not knowing any better, I might just say Well, I got this angle and that side opposite. I've got this side. I ought to be able to find this angle using the law of sines, right? So sine of c divided by 7 is equal to the sine of 52 divided by 2. Good. I know 3 of the 4 things in there. I can find the 4th one. So multiplying both sides by 7, I've got the sine of angle C is 7 times the sine of 52 divided by 2. Now, one of the things that I notice is that I know that the sine's got to be somewhere between -1 and +1. And the 7 divided by 2 is like 3.5. So this has better be pretty small in order to bring it down low enough. And in fact, in this case, I don't think it is. If I try 7 times the sine of 52 divided by 2, it tells me 2.758. 2.758. So C should be the inverse sine of that. Well, you might not even need to plug it into your calculator to know that this isn't going to work. I mean, sine's going to be somewhere between 1 and -1. How the heck could it be 2? So inverse sine can't take a number that's bigger than 1 as its input. It won't give you an output. In fact, if you try it, if I say, give me the sine inverse of that previous answer, this way I've got all the decimal places, it says error, domain. That is, I'm plugging something in that's not within the domain of the function that I'm using. Okay? There is no angle that C could be in order for this triangle to work. This 2 is just way too short. It only comes down, this far. It doesn't make it all the way down to the other side. So that's a no solution situation, right? Let's try the same angle. Try this again here, and we got ourselves a 52-degree angle. We got a side length 7. This is A, this is B. This time let's call this 6. 6. Okay. So what's going to happen? Well, again, this is C. I've got sine of C divided by 7 equals the sine of 52 divided by 6. Now this is sine C equals 7 over 6. Sine 52. Now, see, this is still a little tricky. 7 over 6 is a little bit bigger than 1, so maybe the sine of 52 is small enough. We'll hope. Here we go. 7 sine 52 divided by 6 is 0.919, so we're good here. All right, this is 0.919345, whatever, and so on. So C is going to be the sine inverse of that, of 0.919, blah, blah, blah. So on my calculator, I'm going to say sine inverse of the previous answer, and it tells me C is equal to 66.8306. Now, this is not the only solution, because this is an angle. This 66 degrees here is an acute angle. So it's probably the picture that I have drawn. However, the answer, the triangle, might actually look like this, where the 6 is here and the 7 is there and the 52 is in there, and that we calculated this angle over here, which is that one. Or C might equal 180 degrees minus 66.8306, which is, get my calculator, 180 minus the previous answer, 113.17 or whatever. Right? And with the information given, I don't know which it is. I don't know whether it's the 66 or the 113. Right? Certainly, whatever those two will give you a different angle for B, and the calculation of this other side would be different. So let me see here. I'm gonna use the first one to calculate B. I'm gonna come back to this one. So using this information here, I'm gonna say that B is 180 degrees minus 52 minus that. Let's just go to a couple decimal places here. 66.83. So 180 minus 52 minus 66.83. That's going to give me 61.17 degrees for angle B. And then the side length B down here is going to be calculated with the law of sines. B over the sine of this 61.17 equals given information here, 6 over the sine of 52 degrees. So that's not equals. So B is equal to 6 times the sine of 61.17 divided by the sine of 52 degrees. Right? So here we go. 6 divided by the sine of previous answer. Actually, it's 6 times, not 6 divided by. So 6 times that divided by the sine of 52. Okay. And that gives me B equals 6.67. Right. So I'm looking at this thinking, if C was 61 degrees and B was, no, C is 66 degrees and B is 61 degrees, then the smallest angle is 52, so 6 is the smallest side, and this one is the middle angle, 61, so that should be in between, and the 6.67 is indeed somewhere between the 6 and the 7, so that's good. Okay. Now, if on the other hand the triangle looked like that, then I'm going to do another calculation here and say that angle B would be 180 minus 52 minus this 113.17. So angle B is going to be really pretty small here. 180 minus 52 minus 113.17. And so B turns out to be 14.83. And in this case, it's the smallest angle. I mean, here we had 61 in between those two, but this 14 is definitely the smallest angle, and so that's going to be that side. Calculating side B now, B divided by the sine of 14.83 is equal to, what am I going to use? 6 in the 52. 6 divided by the sine of 52 degrees. So B is equal to 6 times the sine of 14.83 divided by the sine of 52 degrees. And let's do that calculation. 6 divided by the sine of my previous answer. Not divided by, I did it again. 6 times, and then I want divided by the sine of 52. Yay. And I get 1.9488, whatever. Okay. Definitely smaller than either of those other two sides, right? 6 and 7, and I get a smaller one. Okay. If the information you're given is side-side angle, then you don't know enough information to determine which triangle it is. You got to calculate them both, right? We'll find ourselves in a situation like this when we're doing some law of cosines problems, where actually they've given us all the sides first, and we calculate one of the angles using the law of cosines. Okay, then you may be finding yourself using the law of sines, calculating another one of the angles. In which case you got to be careful. Make sure you know if you're calculating a big angle or a small angle. Okay, we'll talk about that when we're doing the law of sines. For the time being, if you're in the situation where you've got an angle side and side and the angle's not in between the two, you run the possibility of two answers. Be aware. The inverse sine will always give you the small angle. You've got to find the supplement to get the big angle. Okay, there we go.